Introduction to Microprocessor 8086. Actually, this topic belongs to the subject microprocessor and microcontrollers with the code name EC8691 under Anna University for the 6th semester ECE department students. Myself, Darwin Brutto, Assistant Professor, Department of ECE. So first of all, I will just explain what basic introduction regarding the microprocessor and what is the history of microprocessor. So when you take the history of microprocessor, this was the period during 1971 to 73. The first microprocessor was invented by the Intel company, and it was a basic processor with 108 kilohertz clock speed, 4 bit of operation. 4 bit means just numerically you can just calculate minus 8 to plus 7 values, just that's all. Very basic numbers can be calculated using this processor, but this was the building block which initiated the invention on microprocessors. And later on in the second generation, in the year 1972, the Intel 8008 was the next evolution from the 8-bit microprocessor. So the first one is a 4-bit microprocessor, the next little bit advanced with 8-bit microprocessor, and later on they just move on with third generation, fourth generation, and finally in the fourth generation they ended up with a 16-bit microprocessor, which we are going to see here, which is the 8086. So previously 8004 was the 4-bit microprocessor, 8008 is the 8-bit microprocessor. Later on, after 1978, I think like in the beginning of 1980s, they started the evolution with the 8086 microprocessor, which is a fourth generation microprocessor. And 16-bit microprocessor had so many applications. It just created awareness to the whole world regarding the electronics, where they developed the electronic applications and projects. Everything were just blooming on this with the help of fourth generation microprocessor. And later on 32-bit microprocessor and 64-bit microprocessor now available in the market. Now present it is available in the market, but 16-bit microprocessor is more than enough for us to construct or develop an application. So that's a history about microprocessor. Now we'll move on to the next introduction to a microprocessor. Basically this 8086 microprocessor, it's having the important and the heart of the microprocessor is a CPU, which is mentioned as central processing unit. Then it has memories, it has input output circuits, etc. And next off, it has a memory which is based on RAM as well as the ROM. So random access memory as well as read-only memory. So read-only memory is actually, we call it as a program memory, where the executing programs has to be stored over there in the ROM, and the RAM actually consists of this data and other executing programs like the data memories, and all these things will be stored in RAM. So we are having two different types of RAM and ROM, but when you take the basic microprocessor which was invented in the year 1970s, like they don't have RAM and ROM separately. There is only one single memory where both the program and the data memory has to be saved over there. Now we will move on to the next. So what is actually the input output section? Input output section is nothing but just a port where the data has to be transmitted to the outside world. It means like the microprocessor can transmit the data from one device to the another. So that's why we are having an input output section where you can transfer the data from one microprocessor to the other microprocessor, or one memory device to the other memory device. Likewise, you can fetch the data from any other memory device towards the microprocessor memory. So there is a need for the input output section. So we are having an input output section over here internally built with the 8086 microprocessor. Then we are having a CPU, central processing unit, where all sort of arithmetical operations and logical operations takes place over here. Basic addition, subtraction, division, multiplication, as well as logical and or operation, everything can be done with the help of central processing unit. The heart of central processing unit is the ALU, which is known as arithmetical logical unit. So this is the basic part of CPU. Next one is we are having an address bus for 8086. Address bus is nothing but it is used for transmission of the signals. So here address bus specifies that it is used only for transmitting the address signals. So each and every memory over the microprocessor, they have an address for identification purpose. So these addresses, details of these addresses will be transmitted through this address bus. These address buses are 16-bit, 20-bit and 24 bits. Depending upon the size of the memory, it may be a 16-bit, 20-bit or 24-bit address. Next. data bus. So likewise, how we are transmitting the address in the address bus, likewise we are going to transmit the data in the data bus. This data bus is like you are having 8 bits, 16 bits and 32 bits with parallel signal transmission, and it is a bidirectional data bus, like you can transmit and receive the data in the same bus. So in some of the processors they usually have a bus for transmission, a bus for reception, but here we are having the same, having the transmission as well as the reception can be done with the same bus. That's why we call this type of buses bidirectional buses. Next one, control buses. Apart from this address bus and data bus, we are having control bus. So control bus, what is the meaning of that control bus? Control bus is nothing but it informs or specifies that whether the operation is done with a read operation or write operation. Read operation is nothing but when the processor is trying to fetch some data from the memory, it is known as read operation, and if the processor is trying to save some data in the memory, that is known as write operation. So these type of things will be mentioned or indicated to the processor that the current execution is a read execution or write execution. So different type of read and writes are there: memory read, memory write, input output read and input output write. So we are having these two type of operations which can be specified by the control bus. Next we are having, next we will see like what is so we have heard the terms like microprocessor and microcontroller. What is these different terms? Microprocessor, what is meant by microprocessor and what is meant by microcontroller? So I will just explain what is the difference between them. So microprocessor is nothing but it is meant for doing several operations. A microprocessor has the ability to do several operations. For example, it can do arithmetical operation, logical operations, and it can go with some other operations too, like whatever the computer operations are done, like transmitting the signal, receiving the signal, and all converting the analog data to digital, digital data to analog. Everything can be done one way microprocessor. But microcontroller is a different one. It can be done, it is used only to do some specific operation, that is some important operation. Only one operation can be done by a microcontroller. Likewise, different microcontrollers can do different operations, but a single microcontroller can do only one operation. For example, you can take the best example is a washing machine. So washing machine is meant only for washing purpose. So there we are using a microcontroller. So microcontroller means it can do only that particular operation. But microprocessor, you can take a mini computer, it's a microprocessor, it has lot of works to be done, so it can do several operations. So this is the main importance difference between the microprocessor and the microcontroller. And just when you go with the efficiency, microprocessors have less efficiency but microcontrollers have more efficiency. Apart from that, there are in microprocessor we don't have the input output memory, input output components and memories internally connected. We have to connect it from external device, like externally you have to connect all these devices for the microprocessor. But microcontroller comes with an internal memory as well as input output components. There is no need of connecting everything internally. So this is some of the difference between the microprocessor and microcontroller. Now we will go on with the architecture of 8086. So look into the architecture of 8086. Just to differentiate the architecture into two different categories. That is, we are having only two parts over there: BIU, which is known as bus interface unit, and the other one is execution unit. So look into the bus interface unit. What all the things we are having? We are having the ALU. Then we are having some segment, some type of registers. I will tell you what are the type of registers present in the bus interface unit later. Next, we are having a instruction stream byte queue, and we are having the interfacing the memory towards this part. That is, bus interface unit is used to interface the microprocessor with the memory devices, as well as it has some registers, and it is having the ALU, and it is having a queue. So that is all present in the BIU, that is bus interface unit. Next we will go on with the execution unit. Execution unit is nothing but where all these operations takes place. In execution unit you will be having the ALU, arithmetical logical unit. Then you are having some operands like operand registers and flag registers. Then basic registers like A register, B register, C register, D register, and stack pointer, base pointer, source index and destination index. These are some of the registers present over here. So I will tell you what is the basic thing happening over here. Bus interface unit is responsible for just connecting the two devices. That is, it connects the memory devices to the microprocessor, as well as it assigns the buses for transmission of address and data. So bus execution unit is just basically used to connection. It is just for the connection purposes. That is, it will connect the two registers for transferring the data or transferring the address, something like that. Then control signals, all these things will be managed by the bus interface unit. Execution unit is going to do the important part over here, that is, it fetches the data from the bus interface unit. It gets the data from bus interface unit. It will perform the operation, maybe adding, addition, subtraction, multiplication, division, something like that. Some operations can be done by the execution unit. After doing after executing the operations, the storing the results and everything will be done by the execution unit. So the data will be again given to the bus interface unit. The bus interface unit will save the data to the particular memory device. That's the actual operation of your bus interface unit and execution unit. So entirely the bus interface unit is going to fetch the data. It is going to give the data to the execution unit. Once the execution is over, the data will again given back to the bus interface unit. Bus interface unit will go and store the data in the memory. So that's all happening here over here. Now we will move on to the just basic things, whatever is happening. Already I have explained the same thing. Execution unit is the important unit where the all the arithmetical and logical operations takes place over here. So for example, let us consider we are going to do an addition operation. We need two datas. So one of the data, both the datas are present in the memory. So what happens is the bus interface unit, it just take the program memory, it just goes to the program memory, it will check for the execution of the program, and it will find that the execution of the program is regarded for addition. So it will go, it will fetch the data, two datas from the memory, it will take it and come, it will just place it in the queue. The queue is like it is a stack memory where first in first out. So whatever the data first it is given into the stack memory, that data will be the first output. So it will store the data in the stack memory, and once the execution unit gets ready for the execution, it will just connect it to the bus interface unit. That is nothing but the stack memory. From the stack memory it fetches the data and it will execute the addition operation. After addition, the added memory, that is the result will be again given back to the bus interface unit. The bus interface unit just receives the data from the execution unit. It will just move on with the data to the particular memory, and it will save it over there, and it will finish off all the operations. This is the actual example for responsibilities of the execution unit and the bus interface unit. Next, pipelining. This type of architecture is a type of pipelining architecture. Pipelining architecture is nothing but this makes the operation very faster. Actually, in the older, in the traditional microprocessor, that is the older microprocessors, we don't have this pipelining architecture. So once the data is complete, once the execution is completed, the next execution will start only after fetching the data and everything. All that formalities has to be completed. Only then the second execution takes place. So what is happening here is we are just wasting the time in between two executions. After first execution, the execution unit has to wait for some time to fetch the data and receive the data and all this. So this takes some time period for this process. So till that the execution unit is free. So what is happening is the process is getting slower. So the if it is slower means the meaning is like the processor is getting is not faster. That is the meaning. Okay. So we have to go with some other method to make it faster. So this pipelining architecture helps us to make the processor faster. For example, I will tell you what is happening over here is when the execution unit is doing an execution, that particular time the bus interface unit will go to the memory, it will fetch the data for the next execution, and it will save it in the stack memory, that is in the queue, stack queue. So what is happening is when the execution unit is executing that current program, the same time the bus interface unit is fetching the data for the next execution, and it is saving it in the stack memory. So what is happening is once the execution is completed, suddenly the next execution will start. Why? Because the data are ready in the stack memory, that is in the stack queue. So what happens, it will fetch the next data and it will start the execution. By that time the bus interface unit will go for the third execution data, and it will collect the data and it will again save it in the queue. So this type of process is known as pipelining. Pipelining is nothing but When the current execution is taking place, the bus interface unit will fetch for the other data. So that process is known as pipelining architecture. When they have introduced the pipelining architecture, our microprocessor, that is our 8086 microprocessor, become faster. For example, if you want to tell, the 16-bit 8086 microprocessor is 4 times faster than the previous processor, that is the 8-bit processor. So what is the reason behind that? Is pipelining architecture is the reason behind that. So that's all about the pipelining. Then we'll see our registers. See, registers plays a very important role here. Why? Because registers are the basic things what we are using for storing the memory, storing the data. So it is like a memory device. Some of the registers act like a temporary storage devices. Some of the registers act like the permanent storage. So here these registers are all made of flip-flops and latches. Flip-flops and latches. What is meant by flip-flop? Nothing but it is just a flip-flop is a device which is used to store one bit of data. So these group of flip-flops or latches together they form the registers. For example, if you are using a 8-bit register, we need 8 flip-flops to save 8 bits of data. So likewise, the registers plays a very important role. For example, you can see here in the architecture diagram, we are having accumulator over here. So accumulator is nothing but it is used for all sort of executions. That is, in accumulator will play an important role. Why? Because when you are adding two datas, one of the data will be in the accumulator and the other data will be in any of the registers. But after addition, the data added value will be automatically saved in the accumulator, and only then it will be transferred to the memory device. So for a temporary storage, accumulator plays a very important role. Here we will see accumulator is also a general purpose data, general purpose register. So here we can see two type of registers we are available, basically general purpose registers and special purpose registers. In general purpose, we can see some type of 16-bit registers which is used to store the data and some other things like temporary storage of data and many other permanent storage of data we are using in the general purpose registers. But in special purpose registers, it is used for the execution purpose and it is used to store the programs and all other things. We are using the special purpose registers. So there are different special purpose registers like segment registers, pointer registers, index registers, flag registers. So all these comes under the special purpose registers. The data register comes under the general purpose registers. So hope these are some of the important points to be remembered from the introduction part of our microprocessor 8086. Now we will see some of the applications. You can see the basic application or the important application of a microprocessor is more or less we can tell just it is used in all the electronic fields. So you can say like it is used in electronic devices like cell phones, kitchen appliances, automobile emission control, timing devices, electronic games, telephone switching systems, thermal control in home and security system. So these are basically more electronic applications are available over here, plus some automobile applications are also there. So you can just tell that microprocessors not only serve the electronic field but also it will serve the mechanical field as well. And nowadays whatever the components what we use in our home, it certainly consists of a microprocessor or a microcontroller. For example, you can take a refrigerator, you can take an air conditioner, you can take a washing machine, whatever may be. All these are made of some type of microprocessor or a microcontroller only. Then microprocessor is used in our personal computer. See, we can tell like a small microcontroller or a microprocessor is like mini computer, is like a mini computer. Without microprocessor, a personal computer is not at all possible. And only after the invention of microprocessor, we are able to get ready with the microcomputer and all. Okay. Then microprocessor is used in laser printers and some other automobile fields like automatic photocopies, etc. So on. So then we are using it in modems, telephones. Already I have told you, in telephones we are using switching systems, we are using digital telephone sets, we are using, and nowadays they are using in the real time applications like air reservation systems and railway reservation systems. See, these are some of the applications what I have mentioned, but more and more there are so many applications about microprocessor. So once we get detail into the topic, though, so we will understand where all we can use these type of microprocessors. According to the conclusion, I will just tell you one of the most significant invention of the technology is our microprocessor. Really, I am telling you, without microprocessor, nowadays our advanced technology wouldn't be possible. We cannot move so faster in this world like using mobile phones, laptops, tablets, so many things. Without the invention of microprocessor, it won't be possible to use all these components nowadays in our life. And So and so in later on versions, this 8086 just a basic microprocessor, but still more advanced microprocessors and microcontroller has been developed now in the field. And but to understand the latest microprocessor and microcontrollers, we have to be very thorough with the 8086 microprocessor. Hope everybody can understand this topic, and thank you.